So far we've been using equations to deal with motion. We also can look at motion on graphs, and we have to be able to figure out the same types of things, acceleration, initial velocity, average velocity, and so on. The first type of graph we're going to talk about is a position time graph. And from a position time graph, you have to be able to describe the motion, and then find the displacement and find the velocity. So if I take a look at this graph, maybe it's a person moving and they're starting at A, 4 meters away from wherever our origin is, where we're measuring from. And then he's moving to this point, okay, where he gets to the origin. So he's moving backward toward the origin. Then he continues backward until he gets to a position of -2. So if I was to look at a number line, he's starting out here at +4, moving backward through the origin, and then ending up at -2 for parts A, B. All right? Now, when we look at these lines, we're going to notice some things. If it's a curved line, that means we're changing speed. And if it's a straight line, it means it's constant speed. And if it's a flat line, it is at rest. Now, for the displacement, that's the difference between the endpoints. Okay, so we're going to say the difference between the endpoints is our displacement. Okay, so for instance, well, I'll get to that in a second. And then the slope is change in y over change in x from math class, but in this case, on our y-axis we have position, or x. On our x-axis we have time. So change in y over change in x becomes change in x over change in t. That should look familiar to us. That is average velocity. Okay, so for the graph above, we're going to look at the two different sections. There's A to B, and then there's going to be from B to C. Okay, for A to B, we said that it's moving backwards, starting at +4 and ending at -2. So we'll say that it's backward. We know that it's backward in this case because it's tilting down. It has a negative slope, and that's going to mean backward. The other thing, since it's a straight line, we said up there the straight line means constant speed, so we're going to note that it's constant speed because it is a straight line. And then we can do a little bit of math, our displacement. Whenever we're finding a change in value, change in x, displacement, we're going to do the final minus the initial. Okay, so the final position was -2 here. The initial position was 4, so it's going to be -2 minus +4. And that's going to give us a displacement of -6 meters. That -6 means it went backward. The fact that it was tilting down means it went backwards, so they match. And then the last thing is going to be our average velocity, which is the slope. In this case, it's going to be delta x over delta t. You should be very familiar with doing slopes from math class. It's going to be -2 minus +4 meters in, and the time goes from 0 to 9. So we do 9 minus 0 seconds, and that's going to give me -6 over 9 is -0.66, repeating, meters per second. Again, and all of these things match. The negative velocity means it's backward. The negative displacement means it's backward. The fact that it's tilting down means it's backward. Now we'll do line BC. For BC, first we'll talk about direction, backward or forward. Well, I start at -2, and then I'm going to go forward to 3, so now I'm going this way on that number line. So I'm going to say that we're moving forward I know that because it's tilting up. And now ask yourself and see if you can figure this out. Is it speeding, constant speed or changing speed? Well, I look at that. It's a curve, so it's changing speed. It's changing speed, I can tell that because it's a curve. Now, if it's changing speed, I really should be able to tell if it's speeding up or slowing down. And if you remember, the slope is the velocity, okay, that's going to help you decide whether it's speeding up or slowing down, because it starts like this, kind of steep, ends kind of flat, so it's getting less steep. The slope is getting smaller. That means the velocity is getting smaller. So it's slowing down. Okay, and again, I can tell it's slowing down because it's getting less steep. And then again, we can find our displacement. Displacement is going to be the final position minus the initial position. And the final position was 3, and the initial position was -2. So that's going to give me 5 meters for the displacement. And then the last thing is the velocity. Okay, again, we're going to have delta x over delta t. I'm not going to do the detail. We already figured out that delta x is +5 meters. And the time that took, it went from a time of 9 to a time of 13. 13 minus 9 is 4 seconds. So we're going to write down here over 4 seconds. And that's going to give me an average velocity of 1.25 meters per second. And it's positive, okay, because it's going forward, and the graph tilts up. All of those things match. So that's it for position time graphs. You have to memorize that the average velocity is the slope, that curvy lines means it's changing speed. The next video is going to be on velocity time graphs. So instead of graphing position versus time, you're graphing the velocity versus time, and it's going to be a different set of rules. So not only do you have to know the rules well, you have to be able to distinguish between each type of graph, and that's what's coming next.